MotoGP was forged in the chaos of 500cc two-strokes, wild, raw, and barely controllable. But rule changes called for evolution. While others played it safe, Honda unleashed a radical five-cylinder engine. It wasn't just an engine, it was a revolution. Let's rewind back to 2001. The MotoGP paddock buzzed with nervous energy as teams prepared for the biggest rule change in decades. Gone were the two-stroke 500cc engines that had terrorized circuits for generations. In their place, a new era of four-stroke engines were born with a massive 990 cubic centimeter displacement limit. The change wasn't just technical, it was philosophical. Racing was about to become more sophisticated, more refined, and more civilized. Every manufacturer faced the same crossroads. Yamaha played it safe with inline fours, drawing from decades of road bike experience. Suzuki followed suit, their engineers confident that proven technology would triumph. Ducati stuck to their beloved V-twins, those torque configurations that had served them well in World Superbike. Even smaller manufacturers like Aprilia considered conventional paths, maybe a triple, perhaps a V4. But Honda decided to go completely insane. While engineers across the paddock sketched conventional 4- and 6-cylinder layouts on whiteboards, Honda's scientists were drawing something that shouldn't exist: a V5 engine. Not a V4, not a V6, a V5. 3 cylinders on one side, 2 on the other, creating an asymmetric engine that defied every rule that had governed motorcycle racing for half a century. When word leaked out during the 2001 testing season, the racing world collectively shook its head. The math alone were terrifying as 5 cylinders create an inherent imbalance. The firing order becomes a nightmare of overlapping combustion events. Heat distribution turns chaotic, with hot spots that could melt titanium. The vibrations should have shaken the bike apart at idle, let alone at 17,000 RPM when everything becomes a blur of controlled explosions. Yet Honda's engineers kept working on this design. Think about the sheer audacity of this decision. Honda wasn't some scrappy underdog with nothing to lose. They were the establishment, the company that had methodically dominated Formula One, built the most reliable road cars on Earth, and took engineering conservatism to its peak. Their reputation was built on making things work perfectly, not on wild experiments that could explode spectacularly. Yet here they were, betting their entire MotoGP future on an engine configuration that existed nowhere else in motorsport. But here's where Honda's genius revealed itself in layers that took years to fully understand. They weren't just building an engine, they were solving a multi-dimensional puzzle that others didn't even know existed. The new MotoGP regulations demanded incredible power output to match the performance of the old two-stroke missiles. Teams needed 240-plus horsepower just to be competitive, but weight restrictions remained brutal. The power figures were absolutely staggering and continuously improved throughout the bike's lifespan. Starting with over 210 horsepower in 2002, Honda's relentless development pushed the RC211V to approximately 255 horsepower at 17,000 RPM by 2006. The torque output reached around 114 to 117 Newton meters, depending on the specific model year and configuration, while maintaining the mandatory minimum weight for 4- and 5-cylinder engines, a regulation that actually favored Honda's unconventional approach. A traditional inline 4, no matter how highly tuned, couldn't make enough horsepower without becoming prohibitively heavy or unreliable. Manufacturers were pushing these engines to 16,000 plus RPM, but the power curves remained frustratingly peaky. A V6 would produce glorious power and silky smoothness, but the weight penalty and packaging nightmare made it impractical. The bike would be too long, too heavy, too unwieldy for the precision that MotoGP demands. The V5, with its carefully calculated 75.5-degree angle and compact dimensions, offered the perfect compromise. More power than a 4, less bulk than a 6, and a packaging advantage that nobody else had considered. The 3-cylinder bank provided the main power stroke frequency, while the 2-cylinder bank added the extra displacement needed for outright horsepower. The technical challenges were astronomical and multiplied exponentially with every design decision. How do you balance 5 pistons dancing at nearly 300 beats per second without creating vibrations that would crack the chassis? Honda's solution for this was pure genius. They offset the center cylinder's crank pin by exactly 104 degrees from the outer cylinders. This wasn't guesswork. This was the result of thousands of hours of computer modeling, dyno testing, and pure trial and error. The offset created a firing order that produced surprisingly even power pulses, while the asymmetrical mass distribution actually helped with chassis balance when cornering. Honda's firing order innovation went even deeper than conventional engineering. They implemented both irregular firing patterns and, for certain periods, Big Bang firing sequences, technology directly inherited from their legendary NSR 500 two-stroke heritage. This approach provided smoother, more manageable power delivery and dramatically improved rear tire traction, solving one of the most critical challenges in translating massive horsepower into forward momentum. Every component told a story of obsessive perfectionism pushed to insane extremes. Titanium valves, each one precision machined to tolerances measured in thousands of millimeters, opened and closed with precision. The valve springs alone cost more than most people's cars, wound from exotic alloys that could withstand the constant stress of 17,000 RPM operation. Dual fuel injectors per cylinder provided accurate fuel delivery. Each injector could meter fuel in quantities smaller than a raindrop, responding to throttle inputs with high reflexes. The technical specifications revealed the obsessive attention to detail. A 20-valve DOHC system that managed airflow with precision, a 6-speed cassette-type gearbox that allowed lightning-fast ratio changes, and a 24-liter fuel capacity strategically distributed to optimize weight distribution. Honda's engineers continuously refined everything from piston ring count to coating materials, switching between 3 and 2 piston rings for weight reduction, while exploring advanced materials and surface treatments that pushed metallurgy to its limits. The exhaust system was tuned not just for power extraction, but for a sound signature that would become legendary. Unlike the angry shriek of inline-4s or the bass rumble of V-twins, the RC211V produced something entirely unique. The sound was so distinctive that fans could identify Honda's approach from kilometers away. When the bike finally hit the track at Suzuka in early 2002, the numbers were absolutely staggering. 240 horsepower at 17,000 RPM, 145 kilograms dry weight, a power-to-weight ratio that embarrassed most Formula One cars. But raw numbers only told half the story, because this machine possessed an almost supernatural ability to adapt to any corner, any surface, any riding style, any weather condition. The chassis innovations were equally revolutionary. Honda pioneered mass centralization by positioning approximately half the fuel tank underneath the rider rather than above the engine, a design breakthrough that dramatically lowered the center of gravity and improved handling characteristics. This innovation was so effective that it became widely copied throughout MotoGP, establishing a new standard for motorcycle design that continues today. The first test revealed something unprecedented, an engine that produced massive power but delivered it with absolute gentleness. But what happens when you push an experimental 5-cylinder engine to its absolute limits in the most demanding motorsport on Earth? Would Honda's massive engineering gamble pay off with championship glory, or will it self-destruct in spectacular fashion? The answer shocked everyone, including Honda's own engineers, who had spent sleepless nights worrying about catastrophic failures. The RC211V didn't just survive the MotoGP competition, it dominated with ruthless efficiency that redefined what mechanical reliability meant at the highest levels of motorsport. Race after race, weekend after weekend, season after season, the impossible engine delivered flawless performance. The reliability statistics were almost embarrassing for competitors. While other manufacturers dealt with blown engines, seized pistons, and electronic failures, Honda's V5 just kept running, and running, and winning. The bike that experts predicted would break down every weekend instead broke records. Honda had somehow created an engine that got more reliable as it got more powerful, defying every assumption about high-performance machinery. In 2002 alone, Honda achieved an almost impossible feat, winning 14 out of 16 races, securing the Riders' Championship with Valentino Rossi, the Constructors' title, and the Team's Championship in a clean sweep that announced the arrival of a new era. This level of dominance was unprecedented and would establish both Rossi's legend and the RC211V's place in racing immortality. Valentino Rossi described it as having an almost human personality. Despite producing enough power to launch small aircraft, the RC211V delivered its violence with gentlemanlike manners that spoiled riders for every other motorcycle they would ever ride. Rossi's relationship with the RC211V became legendary in its own right. The Italian maestro captured back-to-back championships in 2002 and 2003, calling it the best MotoGP machine of the era. Even experienced journalists and test riders who were fortunate enough to sample the RC211V universally praised its surprisingly manageable nature. Despite generating 240 to 250 horsepower, riders described it as a big tiger you can hand-feed, powerful enough to be deadly, yet refined enough to inspire confidence even in first-time testers. The electronic sophistication was groundbreaking for its era. Honda introduced the Intelligent Throttle Control System in 2003, which evolved to full throttle by wire operation by 2006. These systems provided unprecedented linearity and consistency in power delivery, giving riders the confidence to push harder, while the bike managed complex traction and engine braking scenarios automatically. The Unit ProLink rear suspension system isolated suspension loads from the main frame, crucial for managing the immense torque and maintaining optimal tire contact. Traction control algorithms, programmed by Honda's scientists, could detect wheel slip and adjust power delivery quickly. The chassis worked in perfect harmony with the engine's unique characteristics, creating a motorcycle that was simultaneously explosive and docile, depending on what the situation demanded. The frame geometry was specifically designed around the V5's mass distribution, with flex characteristics tuned to complement the engine's power delivery. It was holistic engineering on a level that the motorcycle world had never seen before. Every season brought refinements that left rivals scrambling to keep up with Honda's relentless development pace. By 2003, the engine had grown to produce over 250 horsepower, while actually becoming lighter through the use of exotic materials. New cam profiles extracted power from impossible RPM ranges that should have torn the engine apart. Variable length intake systems optimized breathing for every track condition, from the high-altitude thin air of Brno to the sea-level density of Valencia. The RC211V wasn't just evolving, it was learning, adapting, becoming more dangerous with each passing year, like some mechanical apex predator that grew stronger by consuming victories. Honda's engineers treated each race weekend as a lab experiment, constantly tweaking, adjusting, optimizing based on data streams that rivals could only dream of accessing. Competitors tried desperately to decode Honda's secrets through industrial espionage. Engineers dismantled crashed bikes. Teams analyzed telemetry data with supercomputers, searching for clues in power curves and acceleration profiles. Some manufacturers hired away Honda technicians, offering high salaries, hoping to steal the V5's secrets. But the magic couldn't be copied because it wasn't just one innovation. It was hundreds of microscopic advances working in perfect synchronization, each one dependent on dozens of others in ways that took years to understand. The impossible engine was merely the heart of an impossible motorcycle, and you can't transplant a heart without understanding the entire circulatory system that keeps it beating. The dominance was absolute and terrifying for everyone wearing different colored leathers. From 2002 to 2006, the RC211V claimed 48 victories out of 80 races, a 60% win rate that made competition look like a formality. 3 riders' championships fell to Honda, Rossi in 2002 and 2003, then Nicky Hayden in a dramatic 2006 finale that came down to the final corner of the final race. 4 constructors' titles proved that Honda's supremacy wasn't dependent on any single rider's talent. Tracks from the scorching heat of Malaysia to the freezing rain of Donington Park became Honda's personal playground. The RC211V adapted to every condition with chameleon-like versatility. Rain or shine, hot or cold, fast tracks, or technical circuits, the V5 just kept winning with monotonous regularity. Well, here's the twist. The more complex the RC211V became, the more reliable it got. Season after season, Honda's impossible engine proved more durable than simpler designs from competitors who had decades more experience with their chosen configurations. The five-cylinder layout that should have been a maintenance nightmare instead demonstrated bulletproof consistency that redefined what was possible in racing. The paradox defied logic but revealed Honda's deeper genius. Every component was designed not just to work, but to work in perfect harmony with every other component. The complexity wasn't random, it was orchestrated. The V5's extra moving parts didn't create more failure points. They created redundancy and balance that made the entire system more robust. Maintenance crews reported something unprecedented: engines that actually got smoother as they accumulated race miles. The precision manufacturing tolerances were so tight that components didn't wear against each other. They polished each other to even greater perfection. Honda had somehow created an engine that improved itself through use. Like a fine wine that gets better with age, but happens to produce 250 horsepower while doing it. Race fans developed Pavlovian responses to that distinctive V5 wail. Hearts would race when they heard it approaching from distant corners of the track. Conversations would stop mid-sentence as that unmistakable sound signature announced Honda's presence. But the RC211V's true legacy wasn't just in victories or championships, it was in evolution that continues to this day. This machine forced the entire motorcycle industry to rethink fundamental assumptions about engine design, chassis engineering, and electronic integration that had remained unchanged for decades. Concepts pioneered on the RC211V eventually filtered down to street bikes, making modern motorcycles faster, safer, and more sophisticated than anyone thought possible in 2001. The mass centralization techniques Honda perfected became standard practice across MotoGP. The electronic systems that seemed like science fiction in 2002 now appear on entry-level sport bikes. The holistic approach to motorcycle design, where every component is optimized to work with every other component, became the new normal for serious manufacturers who wanted to compete at the highest levels. When the 990 cubic centimeter era ended in 2006, replaced by 800 cubic centimeter regulations that essentially outlawed the V5 configuration through displacement and weight restrictions, the RC211V took its final bow at Valencia. But its influence didn't fade. It exploded outward like a supernova, inspiring a generation of engineers to embrace the impossible, to question conventional wisdom, to remember that sometimes the wildest ideas produce the greatest breakthroughs. The RC211V proved that in the highest levels of motorcycle racing, conventional thinking is the enemy of greatness. While competitors played it safe with proven formulas that their grandfathers might have recognized, Honda dared to build something that shouldn't exist, shouldn't work, shouldn't dominate. Yet for 5 glorious years, this impossible engine didn't just compete. It conquered everything in its path, leaving a legacy that still echoes through every modern MotoGP grid. Today's MotoGP bikes, with their sophisticated electronics, centralized mass distribution, seamless gearboxes, and radical engineering solutions, all carry DNA from Honda's mad experiment. The RC211V rewrote the fundamental language of motorcycle racing, proving that sometimes the most illogical ideas produce the most logical results when executed with absolute commitment to excellence. So here's a question. Do you think we'll ever see another engineering leap as radical and game-changing as the RC211V? Or has motorcycle racing become too conservative, too regulated, too safe to embrace such beautiful madness? Drop your thoughts in the comments below. And if this deep dive into Honda's impossible masterpiece blew your mind and left you craving more stories of engineering madness, smash that subscribe button because we're just getting started on this journey through the most incredible machines ever built.